An enterprising child in a small school decides to sell lollipops to her classmates. There are 15 other students in her class, so she buys 15 lollipops for 20 cents each, spending $3. Oh yeah, that's right. 15 times 2 would be 30, times 10 would be 300, so $3. She plans to sell them for 50 cents each. She thinks there are at least 3 other children who will definitely want lollipops, but she thinks any number of children, 3 or more, is equally likely. What's the probability that she makes a profit? Okay, there's a lot going on there. If I want the probability in an event, I'm going to need to know what all the probabilities are for everything. I've got numbers here, so I reckon I can make some random variables. So I need a sample space. This child is at the mercy of how all her classmates feel on any given day. So I reckon the sample space is all of those days, all of those feelings that could happen. And then we've got the number of children who buy lollipops. That's a number that's associated with that sample space. So that's a random variable. And we've got the actual amount of money that she makes or loses overall, which is another random variable that's associated with that sample space. So the number of children, we've been told they're equally likely from 3 up to 15, I guess. So that's a uniform, discrete random variable. So I reckon I can make a start using that. I'll give it a name. Let n be the number of children who buy a lollipop. Then n is uniform, discrete, from 3, 4 up to 15. Okay, so that's well, 15 minus 2 to leave the 3 in would be 13. That's 13 options, and so each outcome has probability 1 in 13. Okay, cool. So then there's another random variable, which is how much she actually makes or loses. So let m be profit or loss. So let's see, the amount of money, she's spent $3, so that's minus, and then she's going to gain 50 cents for every child that buys it. So 50 cents times the number of children should be how much she makes. Okay, so each of the options for n has a probability, so each of the options for m has a probability, and all of these give the same, have the same probability. So all of these should have the same probability as long as they're different, because sometimes when you do these calculations, 2 of the inputs produce the same output, and so the probabilities have to join together. But look, this is linear, and so every input's going to give me a different output, and so this is uniform discrete as well. Okay, so all I need to do is just add up how many options there are, because they're all the same probability. So I'm going to need to find the first option where she actually makes a profit. So let's see, when n equals 3, m is 0.5 times 3 minus 3. So that's $1.50 minus 3 is minus $1.50. When n equals 4, m equals 0.5 times 4 minus 3, which would be 2 minus 3, which is minus 1. N equals 5. Okay, so that'd be another 50 cents, wouldn't it? And n equals 6, that'd be another 50 cents, which is going to get us now to 0. And n equals 7, that's the first one when there's a profit. Which is 0.5, 50 cents. Okay, so the probability that the money is greater than 0 is the probability that m is 0.050 up to whatever it is when n is 15. Let me put that in. N equals 15. That's not a, that's a dot dot, like an ellipsis. M equals 15 times 7 minus 3, 15 times, sorry. not 15, 0.5 times 15. So 7.5 minus 3, 4.5. Okay. So number of options goes with the n being from 7 to 15. So that's 15 minus 7, no, 15 minus 6 would be 9. So there's 9 options and each of them's worth a 13th. Okay, cool. I mean, I essentially had to solve an equation there. So I reckon I could have just done this directly like this. The probability that m is greater than 0 is the probability that 0.5n minus 3 is greater than 0, which is, now I can rearrange the inequality in here. 0.5n is greater than 3, divide by the 0.5, n is greater than 6. And so that means that n is from 7 to 15, which is what I figured out anyway, but it's just a little quicker. And since they're whole numbers, a little easier to actually do. So that's 9 times a 13th, which is 9/13. So that's a little quicker, and I might do that next time I do this actually. So I reckon this problem was all wordy, so I should probably finish it off with a neat little sentence. So let's see. The probability she makes a profit is 9/13. Beautiful, done.